Now we come to a concept of the center of mass. Center of mass. Let us try to think. You have a two weights out there, two masses out there. Okay, fine. Equal masses, spherical masses, like in a dumbbell, and they are connected by a massless rod, or say even the rod has the mass. Okay, fine. Now your experience says that if I try to lift it from the center, or I put it on my shoulder, say I put it on my shoulder, perfectly balanced from the center. Suppose so it does not slope down, so something like this, or I put my hand like this, okay, or something like this. Okay, I put my hand like this and try to balance it. Okay, and I try to balance it. Obviously, you know by your experience that it gets balanced, is it not? It gets balanced. No? Somewhere it gets balanced like this. Now your experience also says that if this is say 5 kg, this is 5 kg, and you can say, I do not see you, you are away from me, right? So what I should be feeling is only the mass that is touching my hand. But that experience is wrong. That you never see. You know, even before lifting, that both the masses, they'll kind of apply a force on you. So in effect, even though you are not touching those masses, still those masses, the weight, the force of those masses is felt by you. You put it on your shoulder, fine. You put it in your hand, fine. Is it not? Now for a moment, just try to think. So you had this dumbbell, okay? Someone removes it, okay? Contracts everything into a point mass and gives it in your hand. Will you feel any difference as far as the weight is concerned? No. No. Okay? No. Now this brings us to a very vital and fundamental question in dealing with system of particles, that somehow when I balance it in the center, it so happens that the total mass seems to be acting at that very point. No? It so seems to me that both the whole mass of the system is concentrated at that very point. At least that's what I feel. No, I feel that. I feel that. Because if I close my eyes and someone changes the shape or maybe transforms it into a small ball and gives it in my hand, I'll be applying the same kind of effort, right? The counter force that I'm applying will be the same. That's our experience. Okay? Similarly, suppose you have a lamina. You have a triangular lamina, say like this, okay? And you try to find a point from where you will be able to balance it on your finger. Will you be able to find that point? Yes. Yes. A very simple thing that we used to do when we were class 8th or 9th, it was told to us, you if it is a cardboard thing, you make a hole with a pin and tie a thread into that pin and mark that line. Fine. So suppose I tie it and it turns and say kind of hangs like this. Then we were asked to mark this line. Then you put this pin anywhere else and you again let it float. Okay? And so maybe it will be something like this. So my earlier line was something like this, and it was something like this. Now this line is say something like this. You mark the center, okay, mark the point of intersection, and if you lift it from there, you'll see that it is perfectly balanced, and you'll feel all the weight of that. Obviously, since it is kind of so negligible, it will be a cardboard, so it will not be that heavy, but all the mass seems to be acting at that one point. Okay, so in both the cases, what has happened, though the mass is not concentrated at one point, it seems to be concentrated at one point. There's a difference. They are not concentrated at one point, but they give a feeling as if they are concentrated at one point. And how do I find out that point? You understand? How do I find that point out? Now say if I develop a system like this, so okay, fine, this mass is m, this mass is m, this is my x-axis, okay, this is my x-axis, okay, and I start putting everything in terms of a coordinate. So if this is, I had balanced it bang in the center, so I call that origin O, okay, and this distance I call D, then obviously this was also D. This is still from an experience, but I am trying to develop something. Now obviously the coordinate of this point will be minus D0 and the coordinate of this point will be D comma 0. Is it not? This is x-axis, so y coordinate has to be 0. And somehow the x coordinate and y coordinate of my center of mass, where they seem to be acting, that point I call center of mass, where all the mass seems to be acting like a point. So somehow my center of mass, the x coordinate is 0, y coordinate is 0. So xy is equal to 0, 0. Okay. Now x is what? X is what? See, if the mass was heavier, then I'll have to shift here. Is it not? If one of the masses was heavier, I'll have to go towards the heavier mass to balance it horizontally. Okay? Or if this was there farther, so then also I'll have to shift. So that tells me that my center of mass somehow depends on the mass as well as the distance. That means it is directly proportional to, so the x coordinate is directly proportional to the distance and the mass. We get that point? Of everything, of all the masses. Now that tells me, what if I define it as upon what? Why did I do that? See, I know that it has to be m1 x1. It has to be. And I want a coordinate. If it is m1 x1, it has to be divided by mass, because ultimately it has to be a coordinate. Dimension wise, unit wise. This is currently kg into meter, that has to be divided by kg to give you x, the coordinate, the meter. Is it not? Similarly with y also we have the same kind of thing. After all, y is nothing but x turned by 90 degree. So there also I should apply the same kind of thing. Now if I apply this here, let us try to see whether I get what I have observed. Okay, so if it is m first mass into d plus second mass into minus d upon m plus m, md minus md is 0, 0 upon 2m is 0, so that becomes 0. This is m into 0 plus m into 0 divided by m plus m is equal to 0. You see that? So somehow this formula is able to give me the coordinate where the masses seem to be acting. They are not there. They seem to act there. And later, with experiments, with observations, it was refined and we extended it to a system of particles, any number of particles. So in case of n particles, what happens? X is equal to m1 x1 plus m2 x2 plus m3 x3 plus mn xn upon m1 plus m2 plus m3 mn. Now this is a weird kind of a very lengthy sort of thing, but I know that with the sigma convention, okay, I can convert it with the concept of sigma that you know already from your class 10th. What is that? That tells me I should be writing it as mi xi and summation. This is sigma. This is capital sigma in Greek. Otherwise, there is also a small sigma which is like that. Right? Upon summation mi. Hope you know how to expand this. And we write the lower limit, I is equal to 1, write the upper limit. Here also we write I is equal to 1 and write. How do I expand these things? What do I do? Hold on. This is, I put the initial value, that which is written below. So I is equal to 1. So m1, I put that value wherever there is I. Okay? So it becomes m1 x1. Fine. Then I write plus and increase that 1 by 1. I take it up 1. So it becomes 2. m2 x2. Then I again increase it by 1. Okay. So it becomes m3 x3 and till you go to mn xn upon, what is this? m1 plus m2 m3. I see why I am elaborating on this, because I see children asking me, why can't we write it like this? Summation of the whole. Can I? No. This expanded will tell me what? M1 x1 upon M1. You understand? I am following that principle. What do? I start with I is equal to 1. Put everywhere, wherever it is, you write plus increase I by 1. Then you write the whole thing, increase I by 1. So this will be actually this kind of thing. Mn, xn. Now M1 cancel. So it is actually nothing but x1 plus x2 plus x3 plus xn. Okay, and that would have been evident from here only. I could have cut them. No, it was actually nothing but summation xi.
I have written I is equals to n.
I is equal to m.
N.
No, I is equal to 1. This is I is equal to 1. Sorry. So this has been taken separately, the numerator, and the denominator has been taken separately. Understand?
For y also it will be the same. For y also it will be the same.
Fine. So what is y? Y also becomes the same. So it is m1 y1 plus m2 y2 plus m3 y3 mn yn upon m1 plus m2 plus m3 mn. So that becomes summation miyi, I is equal to 1 to n, upon summation I is equal to 1 to n, summation mi. Correct? And if there was a z coordinate as well, then it is extendable to that too. So what is the z of it? Z becomes m1 z1, m2 z2, m3 z3. No, nowadays you start calling it z, so mn zn. I don't know why or how, but whatever suits you. So that is I is equal to 1 to n mizi divided by I is equal to 1 to n that. Understand? Do we understand that? Now let us try to solve this example 7.1. Let us try to solve this question. It says that the center of mass of 3 particles at the vertices of an equilateral triangle, the masses are this, and each side of the equilateral triangle is 0.5 meters. Now, what do we have? So I put it on the vertices of an equilateral triangle, and while doing so I am absolutely free in assigning my origin and assigning the masses. Fine. So I can take the origin at one of the vertices, or I can take origin at the center of one of the sides. Does not matter. It does not matter. Okay, so let us take one of the coordinates as 0 0 to be here. Why? Because that will make one of the calculations vanish, right? One of the coordinates will simply not appear, and this is how the things look, is it not? Okay, so one of the masses, say 100 gram is here, 100 grams, and say the 150 is here, 150 is here, and say the 200 is here. You are again free to put them in whatever order you want to put them. Okay, now what happens? You will have to find out the coordinate of this. What is the coordinate of this?
0.5.
This is 0.5 comma 0, is it not? What is the coordinate of this?
0.0.
This I know will be midway between this, so the x coordinate has to be 0.25. And what is the y coordinate?
0.25.
See, this is a. If this is a, then this is a by 2 in this right angle triangle. Hope you understand. And a square minus a by 2 whole square is what? A square minus a square by 4, which is 3a square by 4, root over that is root 3 by 2a. So it is at root 3 upon 2a, which is root 3 upon 2 into 0.5, which is nothing but 1.732 into 0.25, 1/4 of 1.732.
Is this?
The y coordinate of this. Okay, 1.7, 1/4 of 1.732, is it not?
Okay, do the side
So
checks.
it is 0.4, it is 0.4, it is 0.433. Is that so? So it is 0.433.
0.43.
Okay. Now what? Do we get that? Now what? I know that x is equal to m1. I consider this as m1 and this as m2 and this as m3. Okay. And we have m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. Obviously, wherever m1 is kept, the coordinates corresponding to that I name as x1, y1, z1. Here there is no z1, z is all 0, right? It is in the same plane. We get the point. Or the coordinates where the mass m2 is kept, that is named x2 comma y2. Where m3 is kept, that is named x3 comma y3. So it is that. What is m1? m1 is 100 into 0 plus m2, that is 200 into 0.5 plus 150 into 0.25 divided by 100 plus 200 plus 150. Now what is that equal to? This is 0, this is 100. 150 by 0.25 is how much? 37.5. Correct? And this is 100. 137.5 divided by 450. Alright? Correct? What is this? 27.5, and this is 90. This is 18 and this is 5.5. So it's 5.5 upon 18. Is it not? So that is 0.306. Is it not? It's 30.65. Right? It is 5. So yeah, it is rounded off to 0.306. That's your x. And what is your y? Obviously m1 y1 plus m2 y2 plus m3y3 upon m1 plus m2 plus m3. What is m1 y1? That is 100 into 0. m2 y2 200 into 0 plus m3 150 into 0.433 divided by 100 plus 200 plus 150. So that gives me 450. So that actually gives me 0.433 into 150 into so much upon 450. Now that gives me 1 by 3, is it not? So that is nothing but 0.144, correct? So your center of mass coordinates are, therefore coordinates are what? 0.306, 0.144, is it not? These are the coordinates. Now it does not matter, and if the book has perhaps taken this 200 here and 150 here, then you will get a different answer. But why you are not wrong? Because if you calculate the distance from 100 gram and 150 gram and 200 grams of the center of mass, that will remain the same. That means relative to the masses, the center of mass is exactly at the same point. You understand? No? We don't understand. Huh? What I am trying to say is, its distance, if you calculate the distance of this point from M1, what is that? That you can calculate? It is what? It is 0.306 whole square plus 0.144 whole square. Root over that. Okay? And whatever is the distance of your center of mass that you got from the book, from the 100 gram mass, that will be the same. Just try checking. You will get the same thing. Same distance. No? Not the same. What is your distance? From 100 gram? From the origin? From the origin or from where? आरी बात समझ पक्का हाँ समझ आना चाहिए. It's very simple thing. It is a very 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 simple thing.